Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the Playfair algorithm. So this is an algorithm for encrypting messages. What we do is we start with a key that's a code word. So I've chosen the code word Canberra. Now this key needs to be kept secret, only the intended recipient should know it. So what we're going to do is we're going to draw up a matrix, a 5 by 5 table. We're going to write in each of the letters of the alphabet. The problem is if we wrote A, B, C, D like that, it'd be really easy to guess. So that's where the keyword comes in. What we do is we first write the letters of the code word like C, A, N, B, but we're not going to repeat the letters. So I'm going to write an R here. I'm not going to write the second R or the second A. So from here, we write the rest of the letters of the alphabet, except I and J are treated as the same letter. That's because it allows us to make a table that's square. It has the same number of rows as it does columns. This won't matter, of course, because when you decipher a message, you'll be able to tell from context whether an I or a J should go there. So we're going to write each of the letters of the alphabet now in order, but we're not going to repeat the ones already used. So I've already used A, B, and C. The next letter I write is D. I don't write E. I've already used it. So I go on to F, G, H. So I and J, I'll just write with I. They're treated as the same letter. Then I'm on to K, L, M. I don't write N because I've already used it. Then I'm on to O, and so on. So we're going to now use this matrix and the Playfair algorithm to encrypt the word blue sky. With this encryption method, you actually encrypt 2 letters at a time. This is actually helpful because what it means is that we don't map the same letter to the same letter. So if you had like an E here and an E here, they could be mapped to different letters, which makes frequency analysis, which is a method of trying to break the code, it makes it that much harder. So we're going to start by encrypting BL using these instructions here. So it says if 2 letters are in the same row, do this. If 2 letters are in the same column, do this. Firstly, we have to determine are B and L in the same column or row. B is in this column, L is in this column. They're not in the same column, they're in different rows. So we're going to use step 3. We are going to draw a rectangle around the 2 letters. So here we have B and L, the 2 letters to be encrypted. They're 2 of the corners. The other 2 are N and M. So we're going to replace BL with N and M. So we choose the one in the row as the first letter that goes first. What does that mean? B was written first. I write N first because it's in the same row. So we're going to encrypt BL as the letters N, M. All right, how would we encrypt U and E? Well, note that U and E are in the same column, so point 2 applies. So we need to move each of them up 1 spot. So U, I'm going to move up 1 spot, is going to be encrypted by O. But E, on the other hand, if I move up, I've got to go around down here. I'm going to move it up 1 spot to Z. So let's look now at S and K. Again, they are in neither the same row nor the same column. So what we need to do is draw a rectangle around them. Turns out to be a square here. S and K are 2 of the corners. L and Q are at the opposite corner. Because S comes before K, I write Q first because it's in the same row. So SK gets mapped to QL. Now we end up with something here like a Y by itself. We need to encrypt 2 letters at a time. So what we might do is just add on some random letter at the end so we can still use this encryption. So we've now got YX. I just chose X as a random letter. So if you decrypt the message and you got blue sky X, you could probably tell X is just an unimportant character. All right, so Y and X, they are in the same rows, so 0.1 applies. So we're going to shift each letter left one spot. So Y goes one spot to X, and X goes one spot to W. Here is my ciphertext. It is gibberish, and hopefully if somebody intercepts this, they wouldn't be able to tell what is happening. But this has the benefit that frequency analysis would be hard. E gets mapped to a different letter, depending on whether it's like next to a U, it would be mapped to a different letter if it was, say, next to a C or next to an R. But this one still is not super hard to break for modern computers. This Playfair algorithm was used, I think, a few centuries ago, but it's a good idea of how we can go about scrambling a message. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.